In this video, let's see how to solve some differential equations by reducing it to linear differential equations. Take up the first problem. Solve e power y into dy by dx plus 1 is equal to e to the power x. We have the standard form of a linear differential equation as dy by dx plus p of x into y is equal to q of x. So that gives here e to the power y into dy by dx plus e to the power y multiply is equal to e to the power x. Now just to compare the standard equation of a linear differential, standard form of a linear differential equation. So here we want p of x into y. So that term nowhere you can see here. So what I can do is there is some q of x, there is dy by dx. This e power y seems to be some extra term. So I will make the substitution, put e to the power y as v. So then differentiate with respect to x, dv by dx is equal to e to the power y into dv by dx equal to e power y. Derivative of e power y is e power y and then dy by dx. So that I got here e power y into dy by dx as dv by dx plus e to the power y, I have taken it as a v, then e power x as it is. See now, it got reduced to linear differential equation in v, variable v, dependent variable is v. Now you know how to solve this using the integrating factor e to the power integral of p into dx. So compare, in the place of p you have 1, in the place of q you have e power x. This is your q, this is your p. So e to the power integral of 1 into dx, which is e to the power x. Therefore solution is v into integrating factor, replace y by v, q into integrating factor with respect to x, because dependent variable only changes, independent variable is x in both the cases, plus some constant of integration c. So v into e to the power x is equal to integral of q is e to the power x into e to the power x integrating factor with respect to x plus c. This is e to the power x plus x is 2x. Integral of e power 2x is e power 2x divided by 2 plus c, v into e to the power x. So we made the substitution v as e to the power y, back substitute e to the power y into e to the power x equal to e to the power 2x by 2 plus c. You can keep as it is, or else you can write e to the power x plus y equal to e power 2x by 2 plus c. This is how we solve the given differential equation by reducing it to linear differential equation. Now let us solve one more problem which is reducible to linear differential equation form. This is the given question. We have a linear differential equation standard form this way. Now when you look at these two equations, on the right hand side you have cos square x and cos y term. On the right hand side we should have only function of x or a constant. So this seems to be an extra term. Divide throughout by cos y. That will help you. Have to look at the RHS. That will help you what term has to be taken to go with the division. So tan y divided by cos y into dy by dx plus 1 by cos y is nothing but secant y into tan x is equal to cos y cancels cos square x. Now we want p of x term here, the tan x let it be. So secant y you have to make substitution for that term. So put v equal to secant x. Sorry, secant y. This is secant y. So now differentiate with the respect to x. dv by dx is equal to derivative of secant y is into dy by dx. So here you got tan y divided by cos y it is. So 1 by cos y is nothing but secant y into dy by dx plus secant y into tan x is equal to cos square x. Now you got tan y into secant y dy by dx as dv by dx, plus I have taken secant y as a v. So tan x into v, which is equal to cos square x. Now it is in the standard form of a linear differential equation in V. So integrating factor is e to the power integral of p into dx. This is your p and this is the q. So e to the power integral of tan x into dx. So which is integral of tan x is the log of secant x. So exponential log cancels. You will get integrating factor as secant x. Therefore solution is v into integrating factor is equal to integral of q into integrating factor with respect to x plus some constant of integration. So v into integrating factor is secant x equal to q is cos square x into secant x with respect to x plus c. Now cos square x can be written as 1 by secant square x. 1 secant cancels, or you just write 1 secant x as 1 by cos x. 1 cos cancels, 1 cos x remains. V into secant x is equal to integral of cos x is sin x plus c. So V value is, we have taken V as secant y. So secant y into secant x is equal to sin x plus c. This is the general solution of given differential equation. So we found the solution by reducing it into linear differential equation by taking the proper substitution here. Put v equal to secant y. I hope you understood. Thank you for watching.